Okay, hello everyone. This is Camilo again. So this is the second video that I'm going to do in English. So the very first video that I did, it was like almost 5 years ago. So I was really young, and also with my English skill either. So okay, today I'm going to teach you how to create like a sheet metal support or sheet metal bracket, and then create a simulation with FEA or analysis, statical analysis, something really basic. It is not something really detailed with the full concept of engineering department or engineering theoric. Okay, so I'm going to start doing something really simple. So I just going to create a, a bracket with the use of sheet metal. So just let me use, for example, 4 inches by 4 inches here. So let me just go to sheet metal, flat base, um, K factor. That is, we can use the gauge table. Um, Inches, we can use the key factor inches simple. So I already have these, the gauge 4 and 5. So well, now you know what I'm going to change because it's really thick, so I cannot just have this thing. I'm going to use the gauge 14 gauge, so it's gonna be better. Okay, so now we're going to just add flange that is going to be from here to here, and I'm going to do this a little bit, like 4 inches, and it's something like this. Properly, just let me edit the material because I want to put something in the stainless steel. um Let me see, where is the stainless steel? Yeah, it's here, stainless steel, but this is not the right one. But well, 304 is stainless steel. So what we just apply, so this is the bracket. I'm going to do something here. I'm going to put some um like this. I don't know how to call this thing, but I'm just going to do this with this feature. I'm going to put this right here, like 0.5 and a half of inch. Let me just put here like full preview, because in order to take a look, always looking previous to apply the changes. From my angle, looks really good. It is not something like strange. So other thing that I'm going to do is a hole in the middle of the plate, or yeah, the plate or the bracket or whatever. I'm going to put like 1 inch, and I'm going just to extrude this thing. So this is okay. Then I'm going to sheet metal. I just want to um, make sure that this plate is, I can unfold this thing. Well, fix it face. Don't worry, just stay there. I can just put it this, collect all bands. Simple. Alright, so from my angle looks really accurate. So I'm just going to suppress this operation, and then I'm going to start doing the analysis for sure. The FEA analysis, that is really important when you are creating these kind of designs. Um, Give me 1 sec, it's still loading, but let me see. Simulation, new study, remember. And now I'm going to do something really, oh my god, my bad, I forgot something. So I'm going to create 2 holes here, like drill holes, but it's not something like difficult. remember these holes that I'm creating is just to simulate that is the part that is going to be bolt with the screws, you know. So let me see, something like half inch this screw is going to be there. So I'm just creating something rapidly, but eventually you will use this kind of model or example of this video in order to do something similar. Just let me put on context. So basically here you will put the screws to bolt or fix this plate, and here is there are something like it could be like weight, or it could be a different item that is going to force this sheet metal to go down, you know what I mean. So well, now I'm going to do this analysis again. So static, for sure that is going to be static. The part, you know, the material of this bracket is already set it up like it is stainless steel 304. The connection we have in here connections, we have connection here. Now I'm going to put fixtures, like for example I'm going to fix the geometry, as you know, this and this. Why? Because it's bolted, remember that. And now I'm going to put an external load. As I mentioned before, I'm going to put something like in force, but in this case I'm going to apply this force not in the entire surface of this sheet metal. No, 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 I'm just going to put here because I'm going to put something there, but I'm going to put not in the surface of the circle area. I'm going to put like a normal, you know what I mean? And then I can just easily select an axis or a line, specifically a line. Then we can just put the force, and if you take a look, the force is going up, and I'm going to put in reverse in order to put like I'm going to put something here. It could be like 100 kilograms, but as you know, if I multiply 100 kilograms per 9.81, like 100 kilograms times 9.81, that is the gravity. It's going to be like 981 newtons. So okay, I already have everything. Now I'm going to, as always, create the mesh, because we need to create a mesh in order to verify everything. I'm going to put this a little bit fine in order to get a good and reliable mesh. This is not, I mean, it's good enough for this exercise. I can refine all of this thing to try to take a look for each component of the mesh, like more um, with like uniform, basically. Then I'm going to run this study like this. Yes, is solving. Um, it's going to be large displacement, but hopefully we'll have a good result for this thing. Okay, so we have already our simulation. So that's the way that it's going to looks like. Um, for sure that we are going to have more deformation here in this part, but we have to take a look what is the real deformation. So in displacement I'm going to put show, and then I'm going to edit definition, and I'm going to put something important that is going to be true scale. It's already in true scale, so that this deformation is real deformation. So we have a big deformation here. So according with these results, the full deformation that is going to be that you can take a look here, that is here. um, Let me see something really important to me. This is the true scale That is something really beautiful. So, as you take a look, the yield strength is already um, is more than the full. Sorry, is less than the um, full value. You know what I mean? So is the full value is going to be 1.69 x 9 exponential 9. So this is more than this. So this bar for sure that is going to fail. Absolutely. What we can do shortly thereafter is just change the thickness of the sheet metal, or we can create some gusts here or something like that. All right, but specifically I just already show you how to do this kind of analysis, so I hope you can get some knowledge from this video and then apply in your industry. All right, thank you so much for take a look or watch this video, and I really appreciate if you can subscribe and follow. Thank you.